Welcome back, everybody. So this is going to be a video going over the review assignment from sections 7.1 to 7.4. I also want to talk a little bit about the upcoming quiz that's tomorrow, just so we're very clear on what the expectations are between the calculator versus the no calculator section. Now remember that it's like a mental math section, right? There's going to be two sheets of paper. The first sheet of paper is the calculator portion. That's just a white piece of paper. The next portion is the mental math portion. It's going to be a yellow piece of paper. Here's what's going to happen tomorrow. You're going to come in. I'm going to give you the calculator piece, the white paper. You're going to have your calculators out. You're going to do everything on that calculator section. And when you feel ready to put the calculator away, that's when you come up and pick up the yellow portion, just like we've done it before. Okay, just like we've done before with the calculator and non-calculator portion. Okay, so and make sure you pick up the corresponding version, whether it be version A or version B, whatever you were handed out at the beginning of class. Okay, and remember, you're not allowed to get your calculator back out once you put your calculator away. Right? Once you get a yellow sheet, your calculator is gone for good. You don't have to be finished completely with the calculator portion. But you just have to be comfortable enough to put your calculator away and not get it back out again. Okay? So you'll do the white portion, the calculator portion. You'll put your calculator away. You'll come up and get a yellow one, and then you'll staple them together and turn them in all at once. You don't have to turn in your calculator portion and to pick up your yellow portion. Does that make sense? Cool. So let me first start off by outlining what could be on the no calculator. I kind of went through and made myself some bullet points here. Okay, on the non-calculator. Okay, on the non-calculator portion, these are the questions that I'm going to be asking you. And this is not just limited to like one question per topic. There might be multiple questions per bullet point. Just depends on how I'm going to ask it. And for non-calculator, I'm going to be asking you to find inverses. And also not only just to find the inverse function, but also to graph it as well. Now, when I ask you to graph it at a calculator, that's just probably just like a simple linear function. I'm not going to give you something crazy like a logarithmic one, but that'll come on the calculator one. Okay, so basic finding inverses and then just graphing the inverse, just a basic linear function. Okay, also changing forms. What do I mean by that? That's going from log to exponential and back again. Okay, there'll probably be a couple of questions just on, changing from logarithmic to exponential to logarithmic. Okay, also, and this is the majority of the non-calculator portion, operations with logs. Okay. What does that mean? That means all the properties of logs. That means addition means to multiply, subtraction means to divide, taking a power means to multiply in front, and reducing all of those accordingly. Think about this. If you're sitting in there on the graphing calculator or on the non-calculator portion, and you're like, wow, I have to do like 17 raised to the fourth power, but you don't have a calculator. There's got to be some other way. Right? If you're sitting there and you're forced to do an operation that's very big and very difficult to do without your calculator, then there's got to be another way. There's got to be a different way to work the problem so that you would not have to use your calculator. Does that make sense? So don't just sit there and be like, oh, no, this is wrong. It's not wrong. You're just doing the problem in a different method that would require a calculator. So do it in a different way that would not require your calculator. Okay. Again, this operations with logs is like that's a majority of the non-calculator portion. That's a lot of stuff in there. All right, so on the calculator portion, and this is a full graphing calculator portion, right? I'm going to be asking you about growth and decay. Okay, and also just not only telling whether a function's growth or decay, but also asking you to graph a function that's growth or decay and telling whether it is growth or decay. What I mean by that is just like those first couple problems that you had in your review assignment, just very simple. You'll have your calculator to do it, so you can use your calculator to sketch. But things that I want to see on a growth or decay function and exponential, growth or decay function, I don't want you to cross an asymptote, and I want you to put the y-intercept in the correct spot. Those are the two pieces that I'm looking for when I ask you to graph an exponential growth or decay. Okay? Those are the two things I'm looking for. Did you put the y-intercept in the right spot? Did you not cross the asymptote? And is it just basically a growth or decay? Right? Did you get the shape of the graph correct? Not only growth and decay with just simple graphing, but also growth and decay in terms of the word problems. Okay? Remember the formula for that is A of t is equal to little a times 1 plus or minus r raised to the t power, whether it's exponential growth or exponential decay. I'm probably going to give you one of each. I'm probably going to give you a word problem with exponential growth, and then I'm probably going to give you an exponential decay. Not probably, most definitely. All right. And then also, there's also right and graph inverse here. Right and graph inverse. We're going to be writing and graphing inverses here. So what does that mean? Well, I could ask you to write and graph inverses in terms of exponential and writing the logarithmic form of it. Okay? I'll give you an exponential function, ask you to graph it. I'll ask you to write the inverse, so given the exponential function, write its inverse. Turn it into a log, basically. Then regraph using that log. Now remember that you don't have to recreate a table or anything, because if you've already created the table for your exponential function, you just flip it to find the table for your logarithmic function. Okay. So right and graph inverses turning from an exponential to a logarithmic, and then just simple free and easy points. I'm just going to evaluate some logs. Okay. So that's either if you have the older type of calculator, the change of base formula, or just free and easy points, just putting them in your calculator. You need the log-based function in your calculator to evaluate the log. So that's what I'm going to be asking you on tomorrow's quiz. In my opinion, and in experience from years past, this is kind of on the easier side of a quiz. I don't want to say that and then not have you guys study it, but in terms of difficulty, this is not on the higher end. This is kind of like on the lower end of the difficulty scale, but still give it its due. Make sure you study. Guys, the most difficult parts, people, I don't know, for some reason struggle with the word problems. Maybe you just don't know the formula, but sometimes people struggle with the word problems and the operations with logs. Okay, that's where people really get a little confused. Yeah, those two places. So make sure you study those. Know your operations with your logs. Okay. All right, so what I would like to do now is just to go over the homework and make sure we know what we're doing. Let me take a picture. Yeah. Got it? You want me to scroll down? You good? We got it. So let's go through here and answer some questions. All right. So we've got 1 to 7 odd, right? This is the correct page, right? 1 to 1, 3, 5. That's correct, right?
Yeah.
These are the correct questions. All right. Tell whether the function shows growth or decay. How do I tell if a function is growth or decay based on the function itself?
If it's less or greater than 1.
If what is less than or greater than 1? Because I see this, like, look, oh, that's got to be growth, right? In the parentheses, the base. If the base is greater than 1, it's growth. If the base is less than 1, then it's decay. So right away, I know we didn't need to do all these, but honestly, quite simply, this is going to be a decay. This is going to be a decay. There's going to be a growth. There's going to be a growth.
Why is the X and 7?
I don't know. Good question. Doesn't really matter on that one, but the inside or outside thing. So here's what I need to see in terms of the graph for each one of these. I'm okay. Again, this is going to be on the calculator portion, so I'm okay if you just use your calculator to sketch the graph. But let's go in here and just graph 1/4 x, 1/4 to the x, excuse me. I'm going to zoom 6. Okay, so this is what I see. If you're transferring this from your graphing calculator to the paper, this is what I want to see. Okay, Where would the y-intercept be? 0, comma 1, right? So this is what I would like to see. Plotted at 1, coming down. Should it cross the x-axis? No. Those are the main things that I need to see. I need to see that it doesn't cross the asymptote and that the y-intercept is in the correct spot. Does that make sense? Okay, so for number 3, I'm going to do the exact same thing, but I'm going to plug it in now. I'm going to do 14 times 1.4 to the x power. I put it outside. Doesn't matter though. I'm going to graph this one. Now, I don't see the y-intercept there. See, I would mark this wrong if you gave me something that looked like this. I would take off a point. Because it almost looks like it's going to go up and not cross the y-axis either. Does it actually cross the y-axis? Yes. Where does it happen? At 14. 1.4 to the 0 power is 1. 14 times 1 is 14. So watch here. I can just simply manipulate my window. See the y values. Let's not put it at 10, but I don't know. It's going to cross at 14. So let's just bump it all the way up to 20. Let's go crazy. Let's just go crazy. Okay, and there it is, right? This is a better graph to see. So let me just pull this one over. A couple things again there. I just need to see where the y-intercept is and that it doesn't cross that x-axis. Are we clear on that? What I see a lot of people might try to do this. You know, give me my function here and just get sloppy. Right? This happens all the time. I will circle that and take a point out for it. Does that make sense? Okay. All right, number 5 there. Suppose that the number of bacteria in a culture was 1,000 on Monday, and the number has been increasing at a rate of 50% per day since then. So the bacteria is growing fast. Write a function representing the growth of the culture per day. All right, so my function, my old function is a of t times is equal to a times 1. Now, is this going to be growth or decay? Is this within the context of the problem? Is this growth or decay? Growth. It's exponential growth. So that means this is going to tell me that this is a 1 plus r raised to the t power. Right? Exponential growth is 1 plus. Exponential decay is 1 minus. All right, so 1 plus r to the t. All right, wait a function. I've got 1,000 as my a value. 1 plus 0.5. You know, inside there is going to be 1 plus 0.5. The percentage is a decimal. So this is really just 1.5 raised to the t power. So there's a of t is equal to, there's my a, right? A function representing the growth of the culture per day. There's my function. Graph the function and use it to predict the number of bacteria in the culture the following Monday. How many days? What's my t value then? Following Monday would be how many days? 7 days. So I'm going to go on my calculator. I'm going to graph this. Y equals 1,000 times 1.5 raised to the x power. And then I'm going to zoom fit this. Should look like an exponential growth. Come on. Come on. There it is. Okay, so there's the graph. And then I'm going to use the graph to predict the following Monday. Okay, so I can calculate the value. The following Monday would be 7 days. 17,085.94. 17,085.94. Okay. That would be the following Monday. Right there. Questions about that? Now, what if I had said, I want to know when the bacteria is going to, how many days it's going to need to be to reach 50,000? 50,000. On what day is it going to reach 50,000? Okay, bacteria. Well, is that an x value or a y value? That's a y value. So I'd go into my calculator and I'd type in 50,000. I'm going to zoom fit this again to try to get my 50,000 in the window as well. I'm going to see my exponential growth coming up. Yeah, look at that. I didn't even change my window. And I see the intersection point here. Second, calculate the intersect. Enter, enter, enter. It's gonna guess at 9.65 days. That's how long it's gonna take to reach 50,000. 9.65 days. Okay. Does that make sense? I just wanted to give you an example of not only finding an x value, but finding a y value as well. All right, so here's number 7. Graph the relation, then graph its inverse. So when I graph number 7, all I'm really asking you to do is just plot the values. And then how would I find the graph of the inverse? What would I do with the x and y? Just split them, right? Just split them. And then the same thing here for the other equations. But let me just jump down here. There is 7. Here's the answer for 7 up top here. So go ahead and check your graph. What should you always see with the graph of an inverse? Good. Reflection over the line y equals x. Basically a reflection over both axes, right? Reflection of the line y equals x. Remember, you should see a diagonal reflection line going through here to here. If you've done it correctly. If you don't see that, then you've done something wrong. All right, we did 1 to 7 odd. Let's do 9 and 10 real quick. Okay. 9 should look like this. I've got, oh, that's an easy one. 9 here. Y is equal to 3/4 minus x. So remember, to find the equation of the inverse, you flip x and y. So x is equal to 3/4 minus y. I subtract the 3/4. Divide by -1. And I put it in F inverse notation. Negative x plus 3/4, or 3/4 minus x, that would have been fine as well. And number 10 here, y is equal to 5x plus 4. So I'm going to switch it. X is equal to 5y minus 4. Oh, sorry, 5y plus 4, excuse me. I subtract the 4. I already got to subtract 4 on the brain. X minus 4 is equal to 5y, and then I divide by 5. I like to write it like this, dividing each part by 5. I'll switch the sign on me. X over 5 minus 4/5 is equal to y, or let's write it in F inverse notation. F inverse of x. Now, what's that?
Can we just write y?
No, because technically F inverse. We're asking for the inverse, so let's be particular about it. Remember that this is going to be on the non-calculator portion, so you just got to know how to graph that by hand. Quite simply, y-intercept is -4/5, and the slope is 1 over 5, right? 1/5 is x over 5. So you just graph accordingly. Let me show you the graphs that are here for 9 and 10. There's 9, and there's 10. Okay. Interestingly enough, F and F inverse have the same graph for number 9. It is symmetrical over the line y equals x. Whoa. Crazy. Okay, any questions on 9 and 10? Okay, let's keep it going then. 13 to 21 odd.
Do you have any recommendations as far as like when you're plugging in different numbers to the equation to get the plots?
Yeah.
What numbers we should do? Should we do like -2, -1, 0?
If it's linear, yes. Or really honestly, you just use your slope and your intercept form.
Okay.
But if it's exponential, I would do enough that you see the curve.
Okay.
However much it would be, because it's not going to be that difficult because you're going to have your calculator. So you might as well just do as many points as you can to see the curve. Because that, in that respect, also, if you plot a lot of points to see the curve, you're also going to have a lot of points to see the log as well. So. All right, so writing from exponential into logarithmic form, we've got again 13 to 21 out. So I'll just show them really quick. So we've got log base 3 of 9 is 2. 15 log base 2 of 0.25 is -2. Okay. Log base 3 of 9 is 2. Log base 2 of 0.25 is negative 2. Number 17, 4 to the third power is 64. And number 19, 0.99 to the 0 power is 1. Those should be free and easy points as well. All right, use the given values. Oh, I guess this tells you which values to use. You know, like I was talking about like number 21, Joy. Like honestly, if I would not be restricted to just using those coordinates, I would want to see the curve. I would want to see exactly what's going on. I'll probably do the same thing where I tell you what to use, just kind of like suggested values that I think you should use. But here's what I'd say here. Let's make a table of values. Y equals y. Why am I doing y first? Come on, I know math. X, comma y, and let's do negative 1, 0, 1, 2, and 3. And let's go into my graphing calculator and figure them out. Oh, get out of there. Okay, so we've got 5/6 to the negative 1. It's just 6/5, so 1.2, negative 1. Positive 1.2, right? Positive 1. 1.2, 0, comma 1, 1, comma 5/6, which is 0.83. 5/6 to the second power, which is 25/36 or 0.69. And then to the third power, which is 0.58. All right, now I am at this point going to look at this and say, okay, well, this is my original. This is my inverse. Well, what does that mean? That means my new x values are the old y values. So 1.2, comma negative 1, 1, comma 0, 0.83, comma 1, 0.69, comma 2, 0.58, comma 3. Okay. I'm also going to write the inverse function as well. Okay, I'm also going to write the inverse function as well. Let me show you what I mean here. The old function was y is equal to 5/6 to the x power. Well, if I flip x and y, 5/6 to the y, I've got to resolve for y. I've got to solve for something that is in an exponent. That means I have to take a logarithm. Log base 5/6 of x is equal to y, or in other words, is equal to f inverse of x. Log base 5/6 of x. Basically, the base of the exponent is now the base of the log when you change it into the inverse. So that would be the equation that I would use to create some more values if I wanted to. Let me show you the actual graph that I've got here. I wonder if it's on this page. Yeah, I'm doing 21, right? Yeah, there's 21. Oh, don't look at any of that stuff yet. I haven't gone over that. But there's my, there are my two graphs. What do I want to see there? Well, for the exponential, I want to make sure that the y-intercept is in the correct spot. So plot our 1 and make sure that it doesn't cross our x-axis. What do I want to see for my logarithmic? Well, I now want to see that the x-intercept is in the right spot, and now you're not crossing the y-axis. Okay, just make sure you're not crossing the asymptote where you should be. 4994988. No, it's okay. Is it you? It's Miss Frizzle. This is my magic school bus. You've reached the magic school bus. All right. So for numbers 22 to 30, 22 to 30. I'll show expressing it as a single log, and then I'll show you simplify as well. Addition means to what? Multiply, right? This one, I don't know. I probably wouldn't ask you 81 times 9 without a calculator, but let's go ahead and do that. Oops, no, second. 81 times 9 gets us 81 times 9 gets us 729. So I just got to figure out, that's my expressed as a single log. I just got to figure out 3 to the what power? 7? Nope, that's too much. 6? There it is. Log base 3 of 729 is 6. Number 23, again, addition means to multiply. So 25 times 5 is 125. So log base 1/5 of 125 is my simplified, okay? My express is a single log. And now I want to take 1/5 to the something power is 125. Well, what flips the fraction? What turns it into a whole number? A negative. And then I've got to take 5 raised to something to get to 125. 3. So that's a negative 3 power. Okay. So express as a single logarithm, then simplify. Now, number 24, I would obviously not be giving you on a graph on a non-calculated portion. But all we do there is take log base 1.2 of, I've got to take 2.16 divided by 1.5. 1.44. So that's my express as a single logarithm. And now I've got to figure out 1.2 to the something power. Let's probably take second power. Hey, that worked. That was nice. Okay, there's my answer. Question about 22, 23, 24? Good there? Okay, for 25, 26, and 27, I've got some more special properties here. Like, I'm not going to try to take 256 squared, but I can take 2 times log base 4 of 256. All right, 4 to the what power is 256? Let's figure that out. Probably 4 to the, no, that's 64. 4 to the 5th? Nope. 4 to the, was I wrong? 4th? It is. 4 to the 4th. So this would be 2 times 4, or in other words, 8. Okay. Just evaluating here, log base 7 of 343. 7 to the what power is 343? I'm going to guess 3. Yep. And now take a look here. That will cancel, right? Same log base as exponent base will cancel. So leaving me just the exponent. Is that 0.73? It looks like 0.73. Move this one out of the way. No. There it is. 0.73. Okay, quite simply, here to evaluate these, let's just put them in our calculator. Remember, I've got to do the change of base formula. You might not have to do that. So log of 243 divided by log of 27 gets us 1.6 repeating. Okay. Number 29. Ooh, sweet, I don't have to change my base. Awesome. Log of 0.01. -2. That one we could have done without our calculator. Log base 5 of 625. So log of 625 divided by a log of 5. 4. All right, questions on any part of the review before I stop the video? No? Okay, I'm going to stop the video real quick. So long, everybody.